Is it okay?
Yes.
Sure. Now let us discuss something about relative velocity. Now when you talk about relative velocity, for example, we have a body A which is moving with some velocity VA, and we have a body B which is moving with some velocity VB. Okay. Now these velocities V and VB are with respect to ground. That means the person is on ground and he is observing the motion. Okay. For him, the velocity of A is VA, and for him, the velocity of B is that fine? But if the frame of reference changes from ground to body A, that means the person is inside the car A. For him, A is at rest. A will not be moving. And he will observe B to be traveling with some other velocity called as the velocity of B with respect to A, or simply the relative velocity of B with respect to A. Is that clear? Is that clear?
Yes.
When the person is inside the car, for him the car is at rest. He's not observed, he does, it's not that he's looking towards right and left. No, there is no noise, there is nothing, there are no jerks. So for him, it is not in motion. Okay? But the person who was traveling ahead of him will not be traveling with the same speed. For example, I have a speed of 10 and there's the guy who is traveling with 20. Okay, for me, he's not traveling at 20. Because per second, the maximum that he can go get away from me is 10 meters. So for me, his speed is 10. It's not at 20. But for a person who is outside our cars, for him, I am at 10, he is at 20. Is that fine?
Yes.
Is that fine?
Yes.
One more observation. Have you observed when you're going this way and there is some other car coming the opposite way, you feel this car was traveling very fast. Shoom, आवाज ऐसी होगी. But would you believe that the people in this car felt you were traveling very fast? That happens. Because unfortunately, you are in this car and you feel like the other one was fast. In reality, both of you feel the other one is fast. Why does that happen? I'll make it. So, relative velocity, whenever we talk about the concept of relative velocity, understand it is very important that whosoever is observing his car, her car will be at rest. Okay? How is that at rest? Just see. That is because from VA, we are subtracting VA. Then only this can be at rest, isn't it? So you have to operate B in the same terms. So what you have to do? B will not be moving with VB. It will be traveling with different velocity, called as what? The relative velocity, yes, of B with respect to, is it clear? And this velocity VBA is given by the velocity of B, which it had, but subtract from it the velocity of A. Is that clear? See, when you subtract VA from VA, this will be 0. When you subtract VA from VB, this is the relative velocity of B with respect to A. So whosoever is with respect to is the observer, and observer should be at rest. Is that fine? Whenever you are solving numericals on relative velocity, whosoever is the observer, just bring him to rest and make the other body do everything. Otherwise, both the cars were doing something. But once this is the observer, this won't do anything. All the work in the same time has to be covered by B. Is that fine? Therefore, B cannot have the same velocity. You have to change its velocity. That velocity is called as relative velocity. Is that fine? Similarly, what if The observer now is inside B. Yes. What will be the velocity of B? Yes, B has to be at rest now. Okay. So A will be traveling with a different velocity, which will be VA, but with respect to B. The relative velocity of A with respect to, and that would be equal to yes, VAB, which is equal to, from VA, you have to subtract what? Is that clear? Is that clear? This is the concept of relative. When the bodies are, when the bodies are going in the same direction, you're just subtracting two, isn't it? Isn't it? Now, for example, I have a different case where the two cars, A and B, are moving towards each other. Okay? And the observer now is inside, say, then the velocity of A will be 0. Isn't it? Isn't it? But the velocity of B would be yes, B, A. Isn't it? Is that fine? So let us find VBA. VBA would be VB is there. So you are taking that as positive, okay? Minus VA. But VA is here, so it has to be minus VA. Is that fine? So what is happening? Yes? VB plus. So when the cars are going opposite direction, the net velocities are getting added up. The relative velocity is the summation. Is that fine? That is why if this car was traveling at 30, this car was traveling at 40, individually when they look at the speedometer, both are slow. But the moment they cross, the person who tries to observe assumes himself to be at rest. So all the velocity will be given to the other car. So for A, B is traveling at 70, and for B, A is traveling at 70. Of course, they are fast. Is that clear? There is the concept of it. Now, where do we use it? I'll take up one problem. Actually, in the previous class at Nahada, Dubai, a student came up with a question, so I had to discuss it with velocity. Now, because this is a case of difference as well, so I discussed it here. Otherwise, we haven't started motion. Okay. I'll discuss with you the case of man and rain problem. Okay? Usually, if you look, if you're just standing without air and everything, rain always falls vertically, isn't it? Isn't it? So you keep your umbrellas like this. But the moment you start to walk, do you still keep your umbrella like this? Why? Because for you, you feel that rain is coming like this. But in reality, at the same instant, if some other person is just at rest, his umbrella is what? Vertical. So the actual motion of rain is vertically down. But once you are in motion, you do not observe rain to be coming vertically down. You are in motion. For you, the rain is coming with a relative velocity as compared to you, with respect to you. Is that fine? Is that fine? So the question they asked in JEE or NEET is, at what angle should you get the umbrella so that your clothes don't get wet? Is that fine? Right. So let us try to solve this problem. Yes, rain is coming like this. This is the velocity of rain. Understand, when I'm saying rain is coming vertically down, it is for a person who is on ground at rest. Okay? So the velocity of rain is vertically down. Is that fine? But now, if there is a person who is going with some velocity of man, okay, his rain is coming like this, so he feels okay. But the moment he starts to travel with some velocity, so he's traveling with velocity what? V m. The question is, at what angle should he keep the umbrella so that, yes, his clothes don't get wet? Is that fine? So, for the man, when the man is in motion, can I say he will not observe rain to be coming vertically down, rather he'll observe rain to be coming with the velocity of rain with respect to man? The relative velocity of rain with respect to man, isn't it? Because initially the man was at rest, rain was falling vertically down. But the moment he starts to move, for him, he is not in motion. It is the rain which is coming in a slanting direction. Is that fine? Is that fine? So that velocity will be the velocity of rain with respect to, isn't it, man? Okay. So isn't this equal to velocity of rain minus the velocity of man? Yes? Yes. So isn't this equal to velocity of rain, and you have to add to it the velocity of man, the negative velocity of man? Right. So let us try to solve it. And let's try to define the direction. Okay. So we have to plot minus Vm. So can I say minus Vm will be somewhere here? Yeah. Yes? Yes. Okay, so there we have two vectors. One is here, other is here. Where will be the resultant? Yes? The resultant will be here. Such to hai. This is what? This is velocity of rain with respect to? Is that fine? Is that fine? Yes. So the velocity of rain with respect to man. Acha, one more thing. Rain is falling. The speed of there is some rain has some speed. Okay. If you start to travel, do the raindrops when they hit you cause more impact?
Yes, yes.
Yeah. So does it feel like rain is moving at a much faster speed?
Yes.
Isn't it? See. The velocity of rain with respect to man in magnitude would be square root of, yes?
V square
VR square plus
Vm square
plus 2 Vm cos of 90. 90. Angle is 90, cos 90 is 0. We don't need to calculate that. Is that fine? See? The velocity of rain with respect to man, when the man is in motion, is not just VR. It is more, it's the hypotenuse. Hypotenuse is the longest side, so that is how you feel the rain is traveling at a much faster speed. Is that fine?
Yes.
And at the same time, you want to find the angle, yes? How do you find the angle? Let the angle it make with this horizontal, say this angle we have to find. This is say beta, okay? So this will also be what? Rain with respect to horizontally, or you can find it with the vertical, no problem. So tan of beta would be what? Perpendicular, which is VR, by base, which is Vm. Is that fine? So you have beta equal to tan inverse VR by Vm. Or you can find the angle with the vertical as well, no problem. But do you understand now, for you, rain is traveling at a much faster speed, and at the same time it is coming at an angle, and if you keep your umbrella like this, your clothes won't get wet. Is that clear?
Yes.
This is the concept. I discussed it because we know difference. And now I also taught you about relative velocity. Is that fine? We'll head into a break. After the break, we'll come up with one more question on training problems. A question. The question is, a man running at 8 kilometers per hour finds rain to be falling vertically down. Okay? Okay? So when he is running at 8 kilometers per hour, he finds the rain to be falling what? Vertically down. Okay? Then, on increasing the speed, to 12 kilometers per hour, so his speed is what? 12 kilometers per hour. He finds rain to be coming at 30 degrees to vertical. The question is, what is the velocity of rain? What is the velocity of rain? Yes. Again, based on the concept that we just studied. Understand this question. When he runs at it, he finds rain only coming vertically downwards. And when he travels at 12, he finds the rain to be coming at an angle.
What is velocity of
Yes. How many of you can do it? Because one of the students actually asked this question in the class. So I thought it's better to show you as well. Yes.
What is your velocity?
12 root 3. How do you do that?
Tan theta for tan 30 to 1 by 3 is equal to
Is equal to what?
b by b fine.
Okay.
Then p is 12 and
Is P 12?
yeah, so yeah, p is 12, so b is rain. Yes, sir.
Is it 4 by 4 into
4 root 3. Anyone else? Anyone else?
what is next term?
Yes.
So it's either
12 root 3
or 4.
Yes, sir.
4 root 3.
Total
Yes, you.
Around
Now, understand this question. The question has two parts. One part is when the guy is traveling with a speed of 8 kilometers per hour. At this moment, he finds the rain is just coming vertically down. Isn't it? And when this guy travels at 12 kilometers per hour, 12 kilometers per hour, he finds rain to be coming at an angle of 30 degree with the vertical, isn't it? Isn't it? Now, this is the vertical velocity of rain with respect to this guy. But what about the horizontal velocity of rain with respect to this guy? It is zero. Because he only finds rain to be coming vertically down. So when the horizontal component with respect to this person is zero, it means that the actual horizontal component of rain is, yes, the actual horizontal component of rain is 8 kilometers per hour. Isn't it? Because then only it will be zero. Is that fine? So the horizontal component of rain is on. We need to find the velocity of rain. The velocity of rain will be actually the square root of horizontal square plus the vertical square, isn't it? First, do you understand why will be the horizontal component of rain equal to 8?
Yes.
Yes?
Yes.
The reason is, see, this guy is traveling at 8, this guy is also traveling at 8. For this guy, this is at 0. because they continuously see each other at the same point, right? So it is at rest. So the velocity is zero. Is that fine?
Yes.
So let me draw it. So the case, the velocity is 8 kilometers per hour, so the horizontal component of velocity will also be 8. 8 and 8 will be 0. That is why in the same direction we have to subtract. So the relative velocity in the horizontal direction will be 0. Is that fine?
Yes.
So horizontal is no. We need to find out. Now he says that when he is traveling at 12, now understand. When one car is traveling at 12, the other was only traveling at 8. Isn't it? If we have to check the relative velocity of rain, the horizontal component, with respect to this car, okay, what we have to do? We have to find, understand, we have to find the horizontal component with respect to the car, okay? So will this be equal to horizontal component of rain minus the velocity of car?
Yes.
Yes? Isn't it? So what is the horizontal component? Yes, it is 8. Subtract, yes, the velocity of car, which is, so the velocity is what? Minus 4. Minus 4 means for the man, rain is going back. Is that clear? So for this person, the velocity is minus 4 kilometers per hour, but in the opposite direction. When this is the case, when he is traveling with 12. Because when he is traveling with 12, the rain was only traveling at 8. So for this person, rain is going back at 4. Because observer is the man, he will consider himself to be at rest. He is not moving. He in reality was going forward, rain was following him, isn't it? At 8. But because he considers himself to see with time what is going to happen, this distance will increase, isn't it? Isn't it? But he is not considering himself to be in motion. He feels himself to be at rest. But the distance still has to increase. How will this distance increase? When this rain will go here. Isn't it? That is why. Is that clear? Any doubt?
So negative 4 is on.
So we can find. No, this is the assumption that he makes. We have to find tangent of 30 degree. How much is that? Perpendicular by base. Perpendicular is 4, base is the vertical component of rain. Isn't it? So we are able to find the vertical component, which is 4 upon, what is tan 30? 1 by root 3, so it is 4 root 3, which is the vertical component. Vertical. So we have to find what?
It won't be negative 4.
Vertical component 4 root negative.
Oh,
So yes, we have to find what? The net velocity of rain. So the net velocity of rain would be square root of, yes.
4 3.
Mm-hmm.
8 square.
Tan 30 is 1 by root 3?
Yes, sir. Yes, sir.
Yeah, so it is 4 root 3 squared plus 8 squared, isn't it? Because horizontal it has. Right. So the square root would be 16 into 3 plus 64. So it is square root 48 plus this 112. So which is
It's like 11.
2 into is it 56? 56. 56 can be written as 28 into 2.
Yes.
So it is 28 into 2. So it is 7 into 4, right?
4 root 7.
So it is 4 root 7 kilometers per hour. Is this clear?
Yes.
Question समझ आया?
Yes, sir.
Rain was not falling vertically. When he was traveling at 8, then only it is vertical. So rain is coming something like this. So when he is traveling at 8, now he feels it's like this. Yes. Okay. अब कुछ बच्चे बोलेंगे सर 4 रूट 3 और 4 रूट 7 में क्या ही फर्क, रूट ही तो ले ना. पता चला 4 रूट 3 वर्टिकल कंपोनेंट. Is this fine?
So that 2 into that.
फिर गलती की मैंने एक ही स्टेप में किया. 112 can be written as. Can you divide it by 4? Yes. How much is it? 4 into what?
28.
Right?
Yes.
But can you write 28 as 7 into 4? So instead of 2 4s, I took 1 out. समझ आ गया? तो ये हो गया आपका man and ring. You have a swimmer problem as well. So we'll be discussing that. Huh? Yeah, swimmer problem along the way. So we can do that question, but we'll be doing the motion. Okay. So yeah, because we were talking about difference, so I thought this. Done? Okay, let's solve one more question. The question is, two cars, it is the easiest, are traveling at 50 kilometers per hour and 80 kilometers per hour in opposite directions. If the distance between them is 400 kilometers, after how much time will they cross each other? Who asked this question? After how much time will they cross each other? Yes.
Forty by 30 hours.
40 by
30. The 40 by 30.
40 by 30. Anyone else?
3.07 hours.
3.07 hours. Okay.
3 point.
So there are two cars. Say one is A and the other one is B. A is traveling with 50 and the other one is traveling at, isn't it?
Yes.
The distance between these two cars is how much? So you need to understand that if they have to cross each other, say they cross each other after time t. Okay. In that time t, A will definitely travel some distance. A will come up to this end, say it travels x, and the remaining has to be traveled by B. Isn't it? Obviously, more will be traveled by B because its speed is more. But after time t, they have to meet. Isn't it? But for an observer who is inside, if this is to happen, he will never assume himself to be in motion. For him, the distance was 400, but B was traveling with a speed of 130 kilometers per hour. Isn't it?
How the distance be 400 if he's traveling?
No. For this guy, initially, when they asked each other, okay, let us meet after some time. For this guy, the distance is 400, but for him, he's not in motion. Who has to cover this distance? B. But B will not travel with 80 to cover this distance. So B will travel with 130.
In A's perspective.
In A's perspective, yes. So it is better to solve this question in that way. So the distance is 400, speed is this, so the time taken would be speed
400.
by distance, right?
Distance by speed, right? Distance.
So time is what? Distance 400 by 130. So it is 40 by
13.
13 hours.
3.07.
3.07. Is it clear?
Yes.
Yes, these questions will be asked in for bullet velocity. So you need to understand what is the limit. Otherwise, you have to equate the times.